Hi everyone. In this video, we want to start a series on elasticity, looking at the definition of elasticity and elastic material, Hooke's law, Young modulus, bulk modulus, and so on. Okay, so this video would we're going to be treating just the definition of elasticity and Hooke's law. Okay, we see here that elasticity refers to the property of a material to regain its original shape and size after it has been stretched, compressed, or distorted. So there can either be a stretching or a compression or distortion. Okay, when a force is applied to an elastic material, it deforms, but upon the removal of the force, the material returns to its original state. So the ability to recover its initial form distinguishes elastic material from non-elastic one. Okay, so that is what elasticity is all about. Okay, so an elastic material is a substance that displays elasticity. Okay, the material can undergo deformation under stress, but have the capability to revert to its original shape. That's the idea, and size once the stress is removed. So we have examples of elastic materials. We can, rubber, certain metals like spring steel, certain plastics, and various natural materials like certain type of wood and rubbery substances found in living organisms. The extent of elasticity in a material is characterized by its elasticity or Young modulus. Okay, the materials, which is the material's resistance to deformation under stress. Okay, so that's what an elastic material is. Any material that, when stressed, returns back to its original state, original size and shape, that material is an elastic material. Okay, so that leads us to Hooke's law. Hooke's law states that the force required to stretch or compress an elastic material is directly proportional to the displacement produced as long as the material remains within its elastic limit. And according to this law, there is a mathematical expression that means F equal to KE. Already, based on Hooke's law, we say F is proportional to X. X is the displacement or the change in length. So with the F, we have F equal to KE, where or KX, where where K is the proportionality constant. It's called the material stiffness or spring constant, representing its resistance. Okay, so let's see certain questions. The first one here, it says a spring has spring constant of 200 Newton per meter. If the spring is compressed by 0.3 meter, what force is applied to compress it? Here we can just simply use the formula F equal to KE. This is K, which is the spring constant, is 200, then times, that should be KX, then times 0.3, which is the change in length or the compression. Okay, so in this case now we get 60 newtons. Okay, so that leads us to the next question. A force of 550 newtons is applied to a stretched spring. If the spring constant is 18 newton per meter, how much does the spring stretch? Okay, we want to know the stretch of the spring. We still use the formula F equal to Kx. So we can say that K is F over, X is F over K. Our F is 50 and our K is 80. That's the spring constant. This is the force. Okay, so that can give us the formula. I think that should be 0.625 newtons. Okay, so that leads us to another question. It says a spring extends by 0.02 meter, that's the extension, when the force of 20 newtons is applied. Okay, calculate the extension if the force of 30 newton is applied to the same spring. Now the best way to go about this question is to start by finding the spring constant. We know that F equal to kx, so we can say that x is F over k, and the force is 20 newtons, where sorry, that's correct then. We have to find the spring constant. Okay, so we can say that our spring constant is F over k, F over x, so our F is 20 and our x is 0.02, and that gives us 1000. So the spring constant is 1000 Newton per meter. So with the spring constant now, we can find the extension when the second force is applied by using the formula F equal to kx. So now my spring constant is 1000, but the force is 30 newtons, so we'll write 30 here. Then we're looking for x, so we can say that x is equal to 30 over 1000, and that would give us 0.3 meters. Okay, yeah, that's a beautiful one. So that is where we stop in this class. Please do well to subscribe to this channel if you are yet to. Thank you very much.